Hello, thanks for clicking. Welcome to another Nargilus 2 production. Today we're going to be learning about the alternating series test. Yet another series test on our adventure to use all the series tests to determine whether series converge or diverge. All right, so let's get started. So, on an alternating series test, well, let's talk first about what an alternating series is. An alternating series is a series whose terms alternate in sign. Okay, so for example, one term will be positive, the next term will be negative, then positive, then negative, then positive, and it keeps going on. Or you could also start negative and go positive, negative, positive, negative, positive. Okay, so that's what it means. All right, so these are two examples of series whose terms alternate in sign. If I substitute 0 in here, that would be 1, right? So I'd get a 0. And then if I put in 1, though, I get negative 1, a1. And then if I plug in 2, negative 1 squared is positive again, a2. And then 3 would give me a negative 1 cubed, a3. And you can go on like that forever. Okay, this is also alternating in sign. It just alternates the other way. So if I substitute 0 in, I get negative 1 to the first. So that's going to be the negative first. And then if I put 1 in, it gives me 2 up there in the power. Negative 1 squared is 1. So that's plus a1. And that would continue on as well. So let's first just see if series are alternating or not. So these are, certainly don't look like those. If you want to determine if a series alternates or not, the easiest way to do it is just literally start plugging in the values to see what happens with the terms. So if I put 0, or the signs, if I put 0 in, 2 times 0 is 0, negative 1 to the 0 is 1. If I plug in 1, 2 times 1 is 2, negative 1 squared is also 1. If I plug in 2, 2 times 2 is 4, negative 1 to the fourth is also 1. So no, this series is not alternating. So what I want you to understand is just because you see a negative 1 with a power, all right, negative 1 with a power here in a series does not necessarily mean it alternates. Okay, so you do have to be careful. You do have to look carefully, because if a series doesn't alternate, you obviously can't use the alternating series test on it. All right, so let's look over here. So this one's a little more complicated. We have cosine n pi times a sub n, starting from 1. All right, so if I substitute 1 in, it gives me the cosine of 1 times pi. Cosine pi, well, cosine's the x-coordinate. I go to the x-coordinate at pi, and it's negative 1, 0 there, so it's negative 1. This is negative a1. The next term, if I plug in 2, is cosine 2 pi. So 2 pi is over here. That's the 0.10. So that's going to be plus a2. If I plug in 3, now I'm at cosine 3 pi. 3 pi, that's 2 pi. That's 3 pi. I'm back here at the negative 1 again. Negative a3. 4 would be 4 pi. 2 pi, 4 pi. Now I'm back over here. Plus a4. This is alternating. This is an alternating series. So again, just by looking at it, it doesn't look obvious that it's alternating, but in fact it is. And since it's alternating, there's a chance that you could use the alternating series test on it to determine its convergence. So with that, let's talk about that series test. The alternating series test, given the series, the sum from n equals 0 to infinity, negative 1 to the n, a sub n, or any alternating series, the series will converge if the following conditions are true. The limit as n approaches infinity of a sub n is equal to 0. So basically, if I take the nth term by itself without the fact that the series is alternating, and I get 0, that's one of the two conditions. Okay? And then the second condition is a sub n plus 1 has to be less than or equal to a sub n for all n, which looks perhaps a little bit confusing. So basically the term every term after the previous term has to be smaller than or equal to the one before it. We call this in math non-increasing. So here's what I mean by non-increasing. 3, 3, 2.7, 2.6, 2.5, 2.2, 2.1, 2.1. This is an example of something that's non-increasing, okay? Consecutive terms can be equal to one another. They can be equal to one another, like these two and these two, but all of the other terms that follow that are not the same have to be less than the previous term. So basically, non-increasing means decreasing or equal to the one before it. All right? These are the two things we have to show to figure out that this series will converge. So this top piece really is almost like the nth term test for divergence, right? You're basically saying it doesn't fail that test, meaning that you get a limit that's 0, first of all, because if you got a limit that was anything else, you would have said, oh, no, forget it. It diverges. Okay? So those are the two things we have to show. All right, so let's take a chance at this. Let's see if this series converges or diverges. The sum from n equals 1 to infinity, negative 1 to the n over n. All right, so first, if I substitute 1 in, I get negative 1. 2 in, I get, there's a 1 up top. 3 in, I get negative 1. So this is an alternating series. All right, so we're going to try the alternating series test. So the first condition for the alternating series test is the limit as n goes to infinity of the nth term without the alternating part. So take out the alternating part. I'd have 1 over n. Well, 1 over infinity. That goes to 0. Okay, it's fine. It passes that. The next thing is that a sub n plus 1 has to be less than or equal to a sub n. It has to be non-increasing. All right, so to do that, again, we ignore the alternating part. We're going to take and we're going to substitute in. So 1 over n plus 1 would have to be less than or equal to 1 over n. All right, so now I don't like to look at this on the bottom here. I'd rather look at it on the top. So we're going to multiply both of these by n plus 1, and n plus 1 to kind of clean it up here. So that knocks that out. That knocks that out. So then n would have to be less than or equal to n plus 1. Well, yeah, n is positive. So, yeah, that's certainly true, right? Okay, you could also do one more step and subtract n on both sides, and then you get 0 is less than or equal to 1, and that's certainly always true. So this is true. It is non-increasing. So this series converges by the alternating series test. And notice that this series without the alternating part is the harmonic series, which we already know diverges, which is kind of a clue to what's going to happen, what we're going to look at in our next video, or one of the videos coming up about different types of convergence, okay? But this series itself converges by the alternating series test. All right, let's try another one. Same idea. Again, we can see that this alternates. That's a negative 1, plug in 2. Now it's positive, plug in 3. Now it's negative again. 4, it's positive again. All right, so the first thing we have to do is find the limit as n goes to infinity of n squared over 5n squared minus 4. Okay, so that's infinity over infinity. It's indeterminate. I could use L'Hopital's rule. I could divide by the dominant power. If I do that, just to say I did it, you probably already know what the limit is. That's fine. But we're going to say we did it just to do it. So that's 1 over, I forgot the limit sign. Sorry. So we have 5 over 4 over n squared. So that's going to be 1 over 5 minus 0. It's 1/5. But that's not 0. Since that's not 0, this fails this condition of the alternating series test. So this series diverges by the alternating series test. I'm done. I'm not even going to go to the non-increasing part. I already know it failed the first part, so why bother with the second? All right, and then last one here. Let's try negative 1 to the n e to the negative n. All right, so first things first. You know what? Let's rewrite this first, I think. Let's try n equals 0 to infinity, negative 1 to the n over e to the n. Let's write it like that. Take this negative power, put it in the denominator. I think that's going to be a little easier to work with. All right. Let's try the limit as n goes to infinity of 1 over e to the n. So that's 1 over e to the infinity. So that's 2.718 to the infinity. Well, that goes to infinity. 1 over something really big goes to really small. That's 0. So that's good. And then we want to convince ourselves that this thing's non-increasing. So 1 over e to the n plus 1 would have to be less than or equal to 1 over e to the n. Okay. So now to do that, again, we can multiply both sides by both of these. There's a couple ways you can do it, but we'll just do it like this for simplicity. These all cancel out. And now we have e to the n has to be less than or equal to e to the n plus 1. Well, yeah, that's certainly true, right? Without a doubt. Okay, if I make the power 1 bigger on this e, yeah, it's going to be a larger value than this one over here because this value is a positive. The other thing you can do is you could split this apart and divide by e to the n, and that would give you 1 is less than or equal to e. Well, that's certainly true. That's 2.7. That's greater than 1. So this is true. It's not increasing. So this series converges by the alternating series test. Okay, and that's it. That's how the alternating series test works. As always, thanks for clicking.